Our next speaker is a self-taught audio engineer with a decade of experience in designing and maintaining audio electronics for professional recording studios. Formerly the head of technology at the Village Recording Studios, she's now the director of hardware engineering at Slate Digital and describes working there as insanely rewarding. So, prototyping is one of her favorite things to do, and one of her goals is to circumnavigate the world on a sailboat. Please welcome to the Hackaday Superconference stage, Erika Earl.
Hi, everybody. So I'm very, very excited to be here. If you see my face turn red and my eyes glaze over and there's like a 30-second long pause, just know that's my happy face. So many of us have ideas about things we want to make. And some of us have ideas about things we want to make that maybe have the power to change the world. How many of you here have already made a prototype of some sort? Just by a show of hands. Cool. How many of you have produced first articles for a pilot production, say? Cool. All right. Yes. But my question for you is, what did it take for this box to get here? Right? It's a good question. I mean, anybody want to take a go at it? Yeah, there's logistics, there's warehousing, there's demand, there's sales. There's a whole business side of this that is complicated. And I'm not going to focus on any of that. I'm going to focus more on how you can take your prototype or your idea to manufacturing and then possibly get into distribution. And some ideas around how that all works. Let's see if this will work. It's very hard. It takes a lot more time than we think it does. You know, with prototyping, you're very excited about things. You'll go for it. And what you'll find is that once you've accomplished or maneuvered one obstacle, you're rewarded with a bigger and harder obstacle. So it's important to, I think, for me, be really passionate about the work that I'm doing because it is so hard. So it's that perseverance and that passion that's going to get you to each one of those new stages. And there's just no greater satisfaction, at least for me, to be able to bring something into existence, especially if other people want to use it and play with it and make art with it. To me, that's the most satisfying, is bridging the gap between technology and humanity and the arts. So I really love interfaces. I really love recording equipment, those types of things. So basically what I just said, creation, it's awesome. And I'd like to share with you some of the things that I've been privileged to work on a team with to bring to mass production. So not quite mass production. The jury's still out. We practiced a lot. There was no prototyping. And some would argue that it was a small miracle that they actually came to be. But one of my favorite projects ever that I got to work on. Two of them, really. This is a 46-inch multi-touch control surface that you can use with the digital audio workstation. And you have the option to use a monitor controller with it. Looks something like this. This will control your speaker outputs, your Q sends, your volume control, your headphone outputs, all of that kind of stuff. This is a dual 27-inch version of the multi-touch console with the monitor controller. Again, you can use any digital audio workstation to record with this. You can use gestures. It's really fun. We've had a lot of fun making these. This is an electronic drum brain and module, which we got to partner with Pearl on, which is pretty satisfying to get that out into the world. And here's me actually working on prototyping that and working on that. It should be noted that all of these things that I've gotten to work on was with a hardware team of 2 people and satellite engineering teams all over the world. So here's our version of the Star Trek Enterprise control room. So this is a triple multi-touch interface solution for recording music. And here's us getting to the box. So it's pretty satisfying. This is my team, my right-hand man, and yeah, we've somehow managed to pull off shipping over 10,000 pieces of hardware to 32 different countries with just a hardware team of 2 people. Thank you. And we did it all in less than 3 years. So that wasn't just us by ourselves. We have incredible industrial designers helping us. We have incredible electrical engineers helping us. We have lots of resources available to us, and it was really all of those people and all of those teams come into play from talking and sharing your ideas about what it is you want to make. And I really loved Anouk's talk because at the end of it, she's like, be awkward, because it is awkward. Sometimes you don't know how to communicate what it is you actually want to make, but the more that we do that, the more people you'll find want to help you make it. And that's important, because there's no way the 2 of us could have pulled off, all of that in that time frame without a whole lot of help from really, really smart people. So I kind of want to get into DFM. There's a lot of acronyms when you start getting into manufacturing that can be quite obnoxious. Suddenly you're hearing DFM and MRP and BOM and all of these things, and it's enough to make your mind explode. But really, what does that mean? And it just means that while you're coming up with these ideas and making these things, it's important to consider, if you want to get it out into the world, how you might design this for manufacturing. Because we have no shortage of ideas where I work. Everybody has lots of ideas, and we have so much fun prototyping them. And sometimes we'll use, interesting tricks to make things work, like gum. But that doesn't really work when you want to repeat it or standardize it. And so what I'd like to encourage you all is, as you go on and make these things, consider designing for manufacturing if that is, in fact, what you want to do. Control procedures and standardization are critical components to mass production. So some of the things that I already talked on, like bill of materials, how many of you are familiar with that alone, just like what that is and stuff? Okay, so yeah, so bill of materials is basically all of the materials that you're going to use to make whatever it is you're going to want to make. We have a tendency, at least on our team, to really go for what's at the edge of technology. So we'll source components that are actually prototypes. Which then become our limiting factors and how quickly we can produce something, because we're now waiting for the chip manufacturer to actually get them to market. But we got samples of them and we're like, yay, we could do this. And then we're like, oh, now we have to wait. So yeah, things to consider. Another thing is end of life. And this one's really, really important, end of life components. So what that means is you sourced a component, and then the manufacturer, the vendor, is no longer going to make it. So what do? You're forced to find a substitute, and that doesn't always work. So keep that in mind when you're prototyping. Do a quick search. Make sure that this thing is not going to not be made anymore, because then you'll be stuck. And then one thing that I learned along the way is grade A+. So it probably means nothing in reality, but I always attach it to anything, to any email that I'm sending for a request for quote from vendors. Adding that plus sign, oftentimes, even though it might be imaginary, gets higher quality components to you. I don't know if this is just my imagination, but I always add the plus sign to it. And then, just double checking that you're getting certified components will help you down the line to meet your compliance. And that could be a whole nother talk. So I just want to touch on it here because it's important that if you know this in advance, when you're looking at your data sheets, you're going to be able to source components that aren't going to poison anybody, they're not going to hurt anybody, they're not going to, you know, your chances of success at meeting like the laws and the regulatory standards that exist in the world are much higher if at the beginning you're sourcing components that have the certifications already worked out in them. And that's really easy. You just look at the data sheets and you double check that they have everything that you might want or need. And it's definitely worth, you know, taking a gander into the myriad of articles online about this early on, just so you're like, okay, got it. And I mean, I guess I'm skipping over all the anecdotal stories that are really funny, so I'm going to try and slow down and give you some examples of some of the things that we've encountered with these things. For example, when I came on, I didn't even know what regulatory standards were. I had no idea until we wanted to ship a product to Afghanistan. And they were like, send us your declaration of conformity, that this isn't going to electrocute somebody. And I was like, oh, okay. Well, how do we do that? Dang it. And it was a pretty lengthy process to figure out. And so this is one super important hack that will help you get to that point of not being in that, oh, how do we get to that? Because it can be very, very expensive, and it can require a lot of engineering change orders after the fact. Okay, so control procedure. Regardless of whether or not you're manufacturing here or overseas, you're going to want to have something that tells whoever's going to be building this thing how to do it. No one is ever going to care more about your product than you. So you may have made 10 of these things, and you put them together by hand with your friends, and now you want to actually see a run of 100 or even 1,000 of these made. And you can't, it's not safe to believe that when you send your design package out, that anyone's going to take that and make it the same way you did because you cared about it. So a great example of this is we sent some materials out to have 100 pieces of something made, and when we made them initially in our pilot production, we did everything by hand and hand tightened all the screws on the boards into the enclosure and very carefully put this thing together, and it was beautiful and it was amazing. And we very carefully detailed our control procedures. We created visual aids, we had assembly videos, we trained the people that were going to be doing this at the factory. And one day I showed up to check on it, and I saw them with a Makita drill and our 6-layer board into the enclosure. And it cracked traces, and it was a disaster that required a lot of late nights to figure out and fix. So I guess my point is, be as detailed in your specifications as possible, and the easiest way to do that is while you're prototyping along the way, while you're considering manufacturing. So you're documenting how you might want to do this. You're including torque specs. You're noting which tools you're using to do it. The devil is really, really in the details, and that's one way to achieve success in manufacturing, is making it so that anyone can make it anywhere. No body English. I have a note that says no body English. Like, in that you shouldn't have to twist or like rub your tummy and pray that it's going to work after you assemble it. It should be easy to make. So design review. So you have your idea, you have your prototype. This is an important time for you to actually look at it and see what you can do to make it manufacturable. And it's important. I walked into a situation whereby I thought we were golden. We had this amazing prototype, and it was just a matter of going through the motions of getting it made, until I started reviewing the design package, and I realized that in there was a hand-drawn schematic, and also the gum. And there were extra nuts and extra standoffs, and there were things that just got it done and it worked, and it was just assumed that, okay, this factory is going to take this and they're going to realize we don't actually need these mechanical fasteners, and like they're going to get bubble yum or spearmint. Like, who cares? They'll figure it out. But that's not how it works at all. So yeah, so review your design along the way. Implement a good discipline of just like check and balances. Have fun with it. You know, if you do need a popsicle stick, use it, but just keep in mind, like, that's probably not going to fly later. And then also, you know, anything that's extra is going to cost you more. So if you don't need it in there, one way of getting to the box is making your design affordable to make. So scrub, 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 scrub. And of course, getting to the box starts with your ideas. So I'm hoping that at the end of this, all of you will continue to create without hesitation and fully know that you're going to make a lot of mistakes. It's just part of the process. You don't have to be afraid of it if you think of American Ninja Warrior. Like, you are being rewarded by it. you know, you get past one obstacle, and then you get to be rewarded with another one. So how did I get here? Why am I speaking to you guys? It was through the power of community. So I think it's really important for every single one of you to actually look to your left and look to your right and high-five your neighbor. This is important. This is really important, because these people are your peers and potentially your future colleagues. I wouldn't be talking to you if I hadn't been brave enough to be awkward and approach a community of engineers who I think are far smarter than I am and ask to be involved. And that's the MindMakers community. And so MindMakers comes here. I can tell you a little bit about MindMakers community. It was started by Michelle Easter, who was a model-turned-mechatronics engineer at JPL. And the mission is to equip and inspire unconventional communities through STEM and education, outreach, and service. And it was in an idea that she had to introduce anybody to mechanical, software, and electrical engineering. And how could we achieve that? So she had this idea of this little building block, this little tool that we could make that would introduce people to binary conversion, and there would be a mechanical assembly involved and a little electronic lesson whereby they could convert their initials into binary, drop in some resistors, close the loop, and create a circuit that lit up. A super simple project that we needed to pull out 75 kits in, I think, like less than 30 days or something like that. And so, no problem. So it landed me here because of her relationship with the lab. And we had decided that we should do this little board in Eagle so that if we had to hand it off to another teammate or volunteer in the organization, that they could also work on it. The only problem is, the only mistake was, I didn't know Eagle. So I was familiar with PC board layouts, and I'm always looking at other engineers' designs. I was like, I'll figure this out. And of course, everyone I talked to in the group was like, yeah, you'll have no problem figuring this out. I know a guy. And I know a guy who figured it out in 24 hours. It's going to be simple. Except for that I forgot that they all work for JPL, and they went to MIT, and like their dad invented C. So I get myself into this position of whereby I've committed to making this little board for this really great cause, and I'm terrified. I don't know what I'm going to do. EEL is not as easy as I thought it would be once I heard them all say that. And so I came here. And I hung out with some folks, wonderful folks here, that helped me get this board finished really fast, mostly just by being my friend. They definitely gave me feedback and encouraged me. I ended up dropping Eagle altogether and going with KiCad. One of the things that we wanted to do is make sure that whatever layout program we were using was accessible to anyone and was free. So I couldn't use the same stuff that we use at work. And so I really want to thank Dan, Hunter, Giovanni, and the team here at SupplyFrame for helping me and MindMakers pull this off. And what we ended up getting to do was go to NASA headquarters to give a hardware workshop to the 2017 Datanauts class. So it was pretty fantastic for somebody who's like incredibly afraid of just about everything. Remember at the beginning when I'm like, I'm gonna turn red, I'll probably glass over, yeah. So it was really fun. And it worked out really well. And yeah, worry be damned. Make a lot of mistakes, because they'll move you forward, you'll make new friends, and you'll make really rad stuff. Thank you. Okay, I knew I was gonna run short. So anybody have any questions? I heard I have a moderator if you're interested. Any questions at all?
So for your typical designs, or if you're contractors or whatever, how many units is your end product typically? And like, do you find that you run into sourcing issues because you're small potatoes, basically?
Yes.
How do you deal with that sort of
Right,
thing?
so the way that I approach it is going to be completely different on the engineering side than how the sales team would approach it. But they'll have a forecast of what they think the demand might be. And what we try to do is rapid prototype and get to market to create the demand in tandem with running a production or a mass production based on the forecast that the sales team has come up with. So those quantities vary depending on what the product is. To answer your question about sourcing, well, actually, let me back up. So that can be anywhere from 100 pieces just to see what the market will say. Like, going really quickly to make something and get it out there and have people play with it is really important, even if it's ugly, because they're probably going to like it, or you're going to know real quick that they don't. So as far as in terms of quantities, I always like 100. Like 100 of something is like, get that out there. Like, see what will happen with that. But in terms of sourcing, yeah, we run into that a lot of times. And that's why I think it's super important in the beginning to consider what substitutions you have. And there are really great resources available to you that will show you what's available in the world based on the economy and what's going on. And that's, that's hit me up and I'll give you 5. So you can definitely do that. Does that answer your question?
Yeah, I guess the even before you hit the 100 mark, right? You've got a prototype 2.
Yeah.
And so sometimes the right component is not. You have to buy 100 or you have to buy 1,000 before you even know if it's the right part. And so, like, how do you deal with?
Oh, if you
vendors
just want samples.
Yeah, yeah. Sometimes that's not even available at 2. You still have to buy 1,000 for the right part, or whatever you think is the right part.
Okay.
It's like, how do you wiggle around the supply chain there to get the 2 that you need?
You make friends. You go to conferences.
Yeah.
You do. I mean, that's really been the secret to my success, because I'm kind of a ninja in this area. It's like, how did you get that? No one else got that. And it's because you go and you meet the people who are making it, and you're like, can I please have one? And sometimes that has to be done by email, and sometimes that can be done by Skype, and it just depends on where they are in the world. We source components all over the world. One of my most favorite components, without saying what it is, comes from Israel. And it's been so fun making friends with those people. But like, it just, I've been a pest, and I'm just like, hey, we really want to work with this thing that you've made, and I need it. Can I just try it? And we've had great success with getting those. Sometimes it requires going and getting the sample yourself by visiting the actual factory that's making them. I don't know that everybody has those resources available to them, but really the bottom line is you have to communicate and talk to people to get what you want if it's going to be in a limited capacity.
Got it. Thank you.
Yeah.
So when you say rapid prototyping, how many prototypes do you make for a product? And do you think I really need the microphone? And how fast do you go through those iterations?
Okay, we go through, well, I've come into projects whereby there were already prototypes there, but they were completely useless. We could not manufacture them. They were unmanufacturable. But then we had the design, like we had the idea and the concept worked out, and that was really important. Like, this works, cool. And then we started from scratch and did it over. And really fast is the answer, I guess.
Days, weeks, months?
Yeah, I would say that it's definitely months, and those iterations can be up to 10 or more, because you're really wanting to get it to that point where you can just say, make this for us. So it's often in the quantities of tens, right? So we're not just producing 1 or 2 boards. We're going to produce 10 boards. We're going to throw spaghetti at the ceiling. We're going to try and build them all different ways at the same time, see what's going to stick and work, and get into a pilot production of 100 pieces, and in tandem already start securing passive penny parts for mass production. We know this is going to be a part of it. Saving all of the active components for later, and any of those really expensive parts for later, but already starting to get the process happening with just a prototype.
Do you consign all your own parts?
Sometimes. It depends on what it is and how sophisticated the design is. So you don't want to pay a 20% markup by having a contract manufacturer do a full turnkey product for you, when you can just go directly to a vendor and purchase components and just ship them to the factory. And that's what consignment is. So you're going to get those really expensive parts by scrubbing your bill of materials, and you're saying, okay, look, we want you to do the electronic board assembly. We want you to even do our mechanical assembly. We even want you to package it. But here, we're going to supply you with the most expensive parts so that we're not getting charged for those, so that we can continue to make it. So, yeah. Yeah.
Sorry, I have one more question, but I think it's particularly applicable to anybody that's in the room thinking about making an electronics product. When you say that you do iterations of 10 and then do a pilot production run of 100, going to, what's a production run for you guys? 1,000 units, 10,000 units?
It depends on which one. It can be anywhere from 1,000 to 10,000 units.
So if you're talking about somebody here that might be looking to make 250 to 500 of something,
yeah.
Like, I know in my experience, the cost associated with doing that prototyping,
yeah,
almost just throws you right out of the ballpark, because we don't have any relationships with vendors that would be willing to say, okay, we'll do a couple of short runs for you because we know we're going to be getting that back end work. Or worst case scenario, the first question they ask is, okay, how many units are you going to be making quarterly? Like, I'm making 250 total, not 2,000 a quarter. So how do you start to establish those relationships when it seems like none of the CMs want anything to do with us?
Right, okay. Well, you become a salesman or a saleswoman. So part of it is, if you are really passionate about it, you have to communicate and build and establish these relationships. And that happens here, and that happens overseas. And it's really just being able to talk about, like, this is what we're trying to do. We need to make sure that this is going to work. We want to make this many of them, and we plan to sell hundreds of thousands of them. I mean, I'll give you a PO for $250 now. What's up? So it is a little bit of peacocking and like, you know, getting there. That's a human being at the other end of it. So whether you're on the phone with them or you're showing up or you're emailing with them, I always make it a point to Skype with any vendor that I'm working with, or at least hear their voice, because chances are I'm going to need them to advance their lead time at some point. And you just make friends. And I mean, that is the way that I've achieved it, is being like, yeah, we can only make $250 right now, and I need every possible break that you can get, and here's everything that I can tell you about this, and here's everything about the market I can tell you about this, and why I'm so passionate about it. So give me the $250. I promise you we're going to get somewhere together, and if not with this one, maybe the next one, but like, let's start this business relationship. And so, yeah, friendship is magic. Oh, that's such a great question. I don't think about it. I just do it.
So always turn the crank.
Always turn the crank. Yeah, you can get so caught up in making it perfect that it might not ever get to market because someone else just came along and just breezed by you and did it. And not that it should be about competition, because I hate that. It's not about that. It's actually about making things that you believe in and getting to that point. And you can one thing that I really like doing is making stuff close by. I want to be able to go to the factory and look at it and see how it's being made, and if we need to implement an engineering change order, be able to do it the same day. And so, yeah, just crank, like go for it, make it. And if money is a thing, which it always is, let it count on the back end and not on the front. Get it right the first time. Just put your money in getting it by cranking it out, because that's when you're going to actually see what's going to work and what's not going to work. And if you need to lower those quantities and they're going to increase the overall price because you want to do 2 prototype runs of 5 pieces each, that's when you tell them, I have a plan to make 500 of these. I want you to loop the first 25 prototypes into the overall projection. So you can safely count on me once I get this right, on knowing that I'm going to make this many. So give me the 25 at the same rate you're going to give me those 500.
At what point during development do you lock down like the scope of the project? Like when you draw the line in the sand that says no more features?
No more feature creep? Right at the beginning. You keep it simple. You keep it simple as you possibly can, without sacrificing what the whole thing is, you know? So yeah, that's in the design review. So you can prototype with all the feature creep you want, and you won't even get to a design review because you're gonna still be prototyping. I mean, it kind of happens right in the beginning. It's kind of like, okay, yeah, this is going to cost an astronomical amount of money to make, and it's going to require 5 years of development. Like, I don't know, no. So then you have to really kind of edit and figure out what it is that you're trying to make, or what problem you're trying to solve, or what kind of joy you're trying to create, or what you want to actually produce. Does that answer your question?
That you would be for 500. If they push back and say they're not going to do it, at what point do you like walk away from that?
I don't.
Okay. So you would just, if they say we're not going to do that, then you just
I find a way to make it work. Okay, so if you can't, like what does that mean? Do I need to give you 30% ahead to secure materials for 500 and you'll give me the 25 at the same price? But then that requires some kind of, you've got to already be in a place where you can commit to whatever that 250 or 100 or 500 pieces are. So I'm in a position where I can kind of do that. So I think I would have to think about how you would do it if you weren't. But yeah, like, okay, look, I know you can secure, I'm gonna give you 30% to secure penny parts, passive parts that I know we're gonna use for a quantity of 250. Come on, give me the 25 prototypes. It's gonna be the same stuff most likely. Maybe you'll add some caption tape to something. Like, do it. I don't know. I get very like, let's play. So, yeah, I don't know if that is a good answer or not, but it's all about just negotiating and creating business relationships with people who want to work with you. So here in California, there are some incredible contract manufacturers and factories, metal fabricators. There's so many creative people here that it really hasn't been a problem for us.
So after doing all the wheeling and dealing and getting the low rate with a promise that you're going to, put out hundreds of thousands of these in the future, has there ever been a circumstance where it didn't happen and then they were pissed?
Well, hundreds of thousands we've never promised, but I've never promised hundreds of thousands. You have to keep it realistic. I mean, you don't want to bullshit anybody. You do want to be passionate about it. But after the wheeling and dealing, was there ever a point whereby we didn't actually, or I didn't actually produce the quantities that we said we would? No.
The biggest fear I have is that someday the CM will return my batch of 100 prototypes that I've done, and one part will be installed backward on all of them.
Yes, that will happen. So you can count on that being one of the obstacles that will happen. And at that point, it's important to figure out how you're going to solve it, whether you're going to request that they fix it, and I would say 10 out of 10 times they absolutely will. So if they make a mistake and you're auditing as you go along, which is important to have some quality assurance measures all along the way that you've worked into it, you can just come to them and say, hey, this part's backwards, you guys got to fix it, and they will. If they won't, then you get a team together and you're up all night for 2 weeks and you fix it yourself.
And then you find another CM.
And then you find another CM. That has happened, actually. That's it. Thank you so much, you guys.